Unit 4, Section 5. Truth Tables 2. Conjunction and disjunction. Session objectives. By the end of this session, the student will be able to construct truth tables relating to conjunction and disjunction signs. Truth Table 2. Conjunction. A conjunction is a combination of two simple statements using the word and. For example, the first statement P can be Kofi is a student, and Q, Kofi is in Form 3. Then the two simple statements can be combined using the word and, which means Kofi is a student and Kofi is in Form 3. And note that for conjunction, the combined statement is only true if and only if the two statements are true. Conjunction table. We saw in our previous slide that for conjunction, the combined statement is only true if and only if both P and Q are true. So therefore, in the conjunction table, if P is true and Q is true, then the conjunction is true. If P is true and Q is false, and since one of the statements is false, the conjunction is false. P is false, Q is true, and since one of the statements is false, the conjunction is false. If P is false and Q is also false, then the conjunction is false. Truth Table 2. Disjunction. A disjunction is a combination of two statements using the word or. For a disjunction to be true, either one of the statements must be true or both must be true. Example, if the first statement is Kofi is a student and the second statement is Amma is in Form 3, then the two statements may be combined by using or as Kofi is a student or Amma is in Form 3. Truth table for disjunction. We saw in our previous slide that when two statements are combined using or, that the disjunction is true if both statements are true or one of them is true. Hence, in the disjunction table, if P is true and Q is true, meaning the two statements are true, so therefore the disjunction is true. If P is true and Q is false, since one of the statements is true, the disjunction is true. If P is false, Q is true. Since one of the statements is true, the disjunction is true. But if P is F, that is P is false, and Q is false, then since none of the statements is true, the disjunction is false. Example on conjunction and disjunction. You have to represent the following statements using logical connectives. A, P or not Q. B, if P and R, then Q. C, P if and only if Q and R. Now for A, In place of or, we use the disjunction symbol, that is P disjunction, the negation of Q, and that is P disjunction caesar Q. B, since P and R, that is a conjunction. So we use the conjunction sign P conjunction R, which implies Q. And C, you have P if and only if. So we use the conditional equivalent sign P if and only if, or P is equivalent to Q conjunction R. Conjunction and disjunction. Suppose that the statement P, the light soup is good. The statement Q, the fried yam is oily. The statement R, the chicken wings are spicy. Translate the following logical statement into words. A, into braces, a negation of P conjunction Q implies R. B, negation of P disjunction R. C, negation of R conjunction P. Let's look at the solution in the next slide. Solution to the question in the previous slide. For us to solve the A, we first have to negate the statement P. The statement P is the light soup is good. So its negation is the light soup is not good. And the statement Q is given to be the fried yam is oily. So we combine that with and. So if the light soup is not good, the fried yam is oily, then it implies the chicken wings are spicy. B, we first have to find P disjunction R, after which we negate that. If you are finding P disjunction R, meaning it is not the case that the light soup is good or the chicken wings are spicy. C, we negate the statement R, that is the chicken wings are spicy. If you negate that, that is the chicken wings are not spicy. Then conjunction P, and the chicken wings are not spicy and the light soup is good. So when we negate that, then it is not the case that both the chicken wings are not spicy and the light soup is good. Conjunction and disjunction. Assuming that P is true, Q is false, and R is true, find the truth value of each proposition. A, into braces P conjunction Q implies R. B, P disjunction Q implies negation of R. C, P conjunction into braces Q implies R. D, P implies into braces Q implies R. Now A, since P is true, Q is false, then we have truth conjunction false. But we know for conjunction to be true, both statements must be true. So P conjunction Q is equal to F, that is false. Now that false implies R, but we are given that R is true. But if F implies T, since the first statement is false and the second statement is true, then it is true. B. P disjunction Q. For P disjunction Q to be true, any of the statements must be true. But since Q is true, meaning P disjunction Q is true, which implies the negation of R. And the negation of R is false. So the truth implies F is equal to F, meaning if the first statement is true and the second statement is false, then the implication is false. C. If you consider the brackets first, F implies T, meaning if the first statement is false and the second statement is true, then the implication is true. So we have the truth conjunction truth. But for conjunction, both statements must be true for the conjunction to be true. Hence, it is true. D. T, that is the truth, implies, because P is given to be true, implies into braces Q, which is F, implies T. So the bracket F implies T means it is true. And truth implies truth is equal to truth. That is T. Truth table show that the negation of P implies Q is logically equivalent to P conjunction negation of Q. Solution. We want to show that the negation of P implies Q is equivalent to P conjunction negation of Q. In the truth table, P is truth, truth, false, false, Q, truth, false. So we negate Q. So negating Q, we have, if Q is true, then it becomes false. So we have false, truth, false, truth. That is, we have negated Q. And since we want to find the negation of P implies Q, meaning we have to find P implies Q. So if P implies Q and P is true, Q is true, then P implies Q is true. If P is true and Q is false, then P implies Q is false. If P is false and Q is true, since the first statement is false and the second is true, the implication is true. P is false, Q is false, the implication is truth. Then we find the negation. The negation, if P implies Q is true, then its negation is false. If it is false, its negation is true. If it is true, its negation is false. If it is true, its negation is false. Now we find P conjunction negation of Q. Now we know that for conjunctions, the compound statement will be true if both statements are true. So P conjunction, the negation of Q, if P is true and Q is false, meaning the conjunction is false. If Q is true and the negation of Q is true, since both statements are true, the conjunction is true. If P is false and the negation of Q is false, then the conjunction of P and the negation of Q is false. If P is false and the negation of Q is true, since both statements are not true, the conjunction is false. Now looking at the table, you realize that the negation of P implies Q, and the conjunction of P conjunction, the negation of Q, are the same. And since they are the same, we conclude that they are logically equivalent. Computation of truth tables. Compute the truth table of, into braces, P disjunction Q, conjunction, negation of P conjunction Q. Now let's look at the table. For P, we have truth, truth, false, false. For Q, we have truth, false, truth, false. So let's find the disjunction P disjunction Q. For disjunction, both statements must be true, or any of them must be true for the disjunction to be true. Hence, if P is true and Q is truth, then the disjunction is true. If P is truth, Q is false, the disjunction is true. If P is false, Q is truth, the disjunction is truth. If both P and Q are false, then the disjunction is false. Now let's look at conjunction. For conjunction, the conjunction is true if both statements P and Q are true. If any of them is false, then the conjunction is false. So if P is true and Q is truth, then the conjunction is truth. But if P is truth and Q is false, then the conjunction is false. If P is false and Q is truth, then the conjunction is false. If both P and Q are false, then the conjunction is false. But we need the negation of the conjunction. So where we have the conjunction being true, now is false. Where we have the conjunction being false is true. So the negation of the conjunction becomes false, truth, truth, truth. Now we want to find P disjunction Q conjunction, the negation of P conjunction Q. So let's look at the columns. So P disjunction Q, the conjunction, negation of P conjunction Q. Now if P disjunction Q is true and the negation of P conjunction Q is false, since both of them are not true, the conjunction is false. When you take the second rule, the disjunction is truth and the negation of conjunction is truth. Since both are true, the conjunction is true. The third rule, we have truth, truth. So the conjunction is truth. The fourth row, we have F and the disjunction, T and the negation. So its conjunction is false, as indicated in the table.